Greetings from my recording studios in beautiful downtown Machu Picchu. And welcome to this third presentation in our series on fractions. And in this presentation, we'll be discussing how to add fractions with different denominators. But before we get into it very deep, let's do a quick recap of the first two presentations. We've already learned how to do prime factorization. And here's an example. Let's say I have 24 and I want to write the prime factors. I'll do it step by step. This is an even number, so we can factor out a 2. 24 divided by 2 is 12. I'll rewrite that 2 again. And then 12 is also an even number, so I'll factor out a 2. And 12 divided by 2 is 6. 6 is an even number. I'll do the same thing. 2 times 2. 6 can be factored into 2 times 3. And those are our prime factors. Let me check. 2 times 2 is 4. Times 2 is 8. Times 3 is 24. So that's a check. We then used prime factorization to get the greatest common factor between two numbers. And let's say that I had 24 and 36. The first thing that I like to do is write them as a ratio like this, and then I'm going to prime factor each one of those. We already have 24, and we know that that is 2 times 2 times 2 times 3. Now we'll do 36. We know that 36 is an even number because the number in the ones place is an even number. So that's going to be 2 times 18. Eighteen is an even number, so I can factor 2 out of that. It's going to be 2 times 9. And then we have in the numerator 2 times 2 times 2 times 3. This 9 can be factored into 3 times 3. So that'll be 2 times 2 times 3 times 3. And now we look for all the numbers that are the same in the numerator and the denominator. We have 2 and 2. So we'll have 2 over 2. We have 2 again. That's going to be times 2 times 2. And then we skip this next 2, and we see that there's 3 up and down. So that's going to be 3 and 3. I'll just cancel out everything that I've already used. And that leaves me with 2 over 3. This becomes our greatest common factor. 2 times 2 is 4, times 3 is 12. It's going to be 12 over 12 times 2 over 3. And that is our greatest common factor. Using the same numbers, we'll get the least common multiple. Recall that was 24 over 36. Whenever we reduced that, whenever we got the greatest common factor, we factored it out. and that left us with 2 over 3. And the final step for getting the least common multiple was to cross multiply. And if we did everything right, whenever we cross multiply, we should get the same result both times. So this is going to be 24 times 3 equals 2 times 36. This looks like 72 equals 72. So I got this identity. And if I got that identity, which is what I'm really wanting, then that's a check. I'm likely to have done everything correctly. To demonstrate how we'll use all of this information to add 2 fractions, let's go back and look at a simple addition subtraction problem. Looks like this. The original equation was x minus 8 over 105 equals 5/84. And we solved that. We rewrote this as an equivalent expression. We zeroed out the 8/105 by adding the opposite, and we're left with this. Now we have to deal with 2 fractions that have different denominators. Remember, you cannot add fractions that have different denominators, so we're going to have to make sure that we have equal denominators before we do any addition. So the first thing I'm going to do, step 1, write the denominators as a ratio. Now, it doesn't make any difference whether you put the 84 in the numerator and the 105 in the denominator, or you just do it the other way with the 105 in the numerator and the 84 in the denominator. I personally like to put the smaller number in the numerator, so I would write 84 over 105. Step number 2, prime factor. Those numbers. Now 84 is an even number, so I'm going to first factor out a 2. 84 divided by 2 is 42. I'll factor the 42 now. I'll keep that first 2. 42 is an even number. I'll factor out a 2. 42 divided by 2 is 21. And since these 2 digits in this number add up to 3, I know that 3 is one of my prime factors for that. And I go through the whole thing. 2 times 2 times 3. 21 divided by 3 is 7. Those are the prime factors for 84. And then 105, I'll factor that. 105 has 5 in the ones digit place, so I know that 5 is one of the factors. So that would be 5 And 105 divided by 5 would be 21. Once again, 21, we already know that 21 has the factors of 3 and 7. So this would be 5 times 3 times 7. And then step number 3 is get the greatest common multiple. So we had 2 times 2 times 3 times 7 over 5 times 3 times 7. The only thing that's common to both the numerator and the denominator are these two numbers. That's going to leave me 2 times 2 over 5 times 21 over 21. This is my greatest common multiple. I'll go ahead and cancel him out, and that leaves me with 4 over 5 equals 84 over 105. Please notice that 84 is the smallest number. In this ratio, you would expect that the smallest number in the numerator in the reduced fraction would also be the smallest number, and you do see that. 4 is smaller than 5. 84 is smaller than 105. So step number 2, I have 84 divided by 105 equals 4 over 5. And now we're going to get the least common multiple. And to get the least common multiple, I cross multiply. It'd be 84 over 105 equals 4/5. I'll cross multiply, and I think that 84 times 5 should equal 4 times 105, and that's going to be 420 equals 420. 420 is my least common multiple. Notice that this 5 is associated with that number. This 4 is associated with this number. This is the small number times the large number. This is the large number times the smaller of the numbers. And now we'll go back and we want to add. Let me go ahead and do this, get a new page, give myself some room. 5 over 84 plus 8 over 105. Now remember that we had 84 times 5 equals 105 times 4. And I said that this number 4 is associated with that 105. So whenever I get the common denominator, I'm going to multiply this number by 4, this denominator, and I'm going to multiply this denominator by 5. But I'm not quite finished yet. If I just multiply the denominators, it changes the value of these fractions. We don't want to do that. But if we multiply each of those fractions by 1, nothing changes except the way it looks. So if I multiply the denominator by 5, I have to multiply the numerator by 5 also. And over here, I multiplied the denominator by 4. I'm going to multiply the numerator by 4. You'll recognize that 5 divided by 5 is 1. 4 divided by 4 is 1. So all we've done is multiply each of these fractions by 1. That's going to change the way they look, but it's not going to change the value. Remember, this is called the multiplicative identity. Any number times 1 equals the same number. So at the end of the day, once I make this multiplication, it's the same value, it just looks different. 5 times 5, remember to multiply fractions, we multiply straight across. And we'll get 25 over 420 plus 4 times 8 is 32, and 4 times 105 is 420. Once we have a common denominator, the least common denominator, the least common multiple, to add fractions, you just add the numerators and keep that same denominator. 25 plus 32 looks like 55. Over 420. So 55 over 420 looks pretty good. But I notice that I have a 5 in the ones place, and I have a 0 in the ones place. That means I can factor this down. I can reduce this fraction. This will be 5 times 11. 55 divided by 5 is 11. I can factor out a 5 here, and I think that's going to be 84. Those 5s divide out, and ultimately I'm left with 11 84ths equals 5 84ths plus 8 . And if I go back into the equation, I would write this: x equals 11 over 84ths. Okay, so that's it. So there's a lot there. Remember that whenever we're adding fractions with different denominators, we have to get a common denominator, and we're hoping for the least common denominator. We start off by writing the denominators as a ratio, prime factoring each of those numbers, the numerator and the denominator, canceling out the greatest common multiple. That leaves us a reduced fraction, and then we cross multiply, and that gives us the least common multiple, and then we plug it back into the addition and multiply the numerator and the denominator by those factors that we determined earlier. that wraps that up. There's only one thing left to say, and that is my S actually looks like an S this time. Ladies and gentlemen, thanks for watching, thanks for learning. Be safe, con cuidado.